Okay, so yesterday we did graphing systems of equations. Today we're going to do graphing systems of inequalities. So remember, an inequality has that less than, greater than, less than or equal to, greater than or equal to sign. So when graphing inequalities, there is only one way to solve a system of inequalities, and that is by graphing. You cannot solve it like a system of equations algebraically. So if you have a less than or equal to and a greater than or equal to sign, those are going to be solid lines when you go to graph. And when you have a less than or a greater than sign, those are going to be dashed. So kind of just like when we are putting them on a number line, if you have a less than or a greater than sign, it's an open circle. If you have that equal sign with it, it's the filled in circle. So solid line when you have the equal sign with it, dashed line when you do not. So with systems of inequalities, there's also shading, because you have any answer either that's greater than or less than that will make the system true. So if we look at this, we have x plus y is less than 1, less than or equal to 1, and x plus y is less than or equal to negative 1. So again, you want to put those in y equals mx plus b. So if we have x plus y is less than or equal to 1, getting y by itself, subtracting x from both sides. So we have y is less than or equal to negative x plus 1. So this becomes y equals negative x plus 1. And then the second one, x plus y, is less than or equal to negative 1. Again, subtracting x from both sides, we have y is less than or equal to negative x minus 1. So same slope. So we're going to have parallel lines. So when we did equations, when we had parallel lines, there was no solution. However, when we go to do inequalities, there is going to be a solution. So if we have both of these, if we want to plot our point on 0, 1, and then our slope tells us to go down 1 and over 1, and we can go down 1 and over 1 again, or we can go up 1 and over 1. So this line is, since it's less than or equal to, is going to be solid. Same thing with the other one. We are going to plot negative 1 first. And then with my slope, I'm going to go down 1 and over 1. Or I can go up 1 and over 1. And I'm going to have that. So we have two parallel lines right now. So if we look at these when it comes to the shading, if y is less than or equal to, you'd shade below. So less than or equal to, or just less than, you're going to shade below the line. And if it's greater than or equal to, or just greater than, you're going to shade above. So with this, both of these are less than or equal to. However, you're not going to shade between with this. Since this is less than, so you're going to go below the red line. You're also going to go below the green line. So your shading is actually any number below your green line. So anything below that green line is going to make this system true. Okay? So your shading, you would just shade, you could scribble below that green line. So there's what that looks like. Now if we move on to the second one, the second example, again, they're not in y-intercept form or slope-intercept form. So we need to put them there. So we have 5x minus y is greater than or equal to 3. Getting y by itself, so subtracting 5x from both sides. we'll have negative y is greater than or equal to negative 5x plus 3. And then we have to divide by negative 1 to get that negative sign away from the y. But remember, when you divide by a negative in an inequality, you have to flip your sign. So y is going to be less than or equal to 5x minus 3. So this equation is going to become y equals, or y is less than or equal to 5x minus 3. And if we go ahead and do that second equation, if we have x minus y is less than negative 1, we're going to subtract x from both sides. Again, negative y is going to be less than negative x minus 1. And dividing by negative 1, y is going to be greater than, because we got to flip, x plus 1. So this becomes y is greater than x plus 1. So we have those two lines. We're going to go ahead and graph them. So y is less than or equal to 5x minus 3. I'm going to put my first point on 0, negative 3. I'm then going to go up 5, so 1, 2, 3, 4, 5, and to the right 1. And on your graphs on your worksheet, it only goes 5 notches.
We'd like to congratulate Miss Katie Lawrence, Woodrow Wilson High School's Poetry Out Loud champion. She will represent Woodrow Wilson in the virtual state competition. Thanks, Katie.
So then your line here is just going to be solid since it's less than or equal to. So that's going to be that line. And then if you have our y is greater than x plus 1, so the first point is going to be on 0, 1. And from there, I'm going to go up 1 and over 1. Or I can go down 1 and over 1. But this time we have this greater than sign. So that means we're going to have a dashed line. So my line will be dashed, and make sure you make it dashed if you have that symbol. So we do have a point of intersection, but that's not our solution. So if we look at this, when y is less than or equal to 5x minus 3, that means anything on this side of the line, because these are all numbers less than, anything on this side of the line would get shaded. And if this one greater than, that means anything on this side of the line is going to get shaded. So you got to find the common ground on where the shading meets. So this one is greater than, so above this line, so that put me in this area. And then this one is less than or equal to, so below, so it's going to be in this area right here. So greater than is going to put me here, less than this is going to put me there. So your answer for shading is just going to be this space right in here for this problem. So it's greater than this line and it's less than this line. So you're going to have your shading right there. And those are the two examples for graphing inequalities. Your worksheet is posted on Schoology. Go ahead and keep that in your notebook. And that'll be it for today.